Okay. Hi, everybody. Good morning. So today I'm going to show you a flow. It's called the electrothermal in dynamic link flow. Okay, so here's the agenda. First, I need to let you know why we're using this flow. And the second, I'm going to give you the step-by-step instruction on how to realize this flow. And the third, I'm going to actually show you another alternate dynamic link thermal flow. I think it's more accurate. And I'm just going to show you more examples of the express T cells, because to realize this flow, express T cells flow is very critical. Okay. First one, why do we use dynamic link thermal flow? The reason for that is the thermal engine actually is very accurate. But to do the RFIC thermal, you need to be inside ADS. But a lot of the PDKs, they're inside the virtuoso environment. So the virtuoso users really desire to use the thermal in ADS. That means that we need to find a link to link between ADS and the virtuoso environment. And to do this, we have two flows. One is called the interoperable flow, and the other one is called a dynamic link flow. Okay, so depends on the PDK, right? If your PDK is not interoperable, then you will need to use the dynamic link thermal flow. So let's talk about the thermal first, right? So I think you guys already, understand this very well. I'm just giving a review, okay? So usually when you need to do the thermal, you have a schematic in ADS side, and you also have a layout on ADS side. And then you're going to run the circuit simulator in the schematic side. You're going to read in the temperature and write out the power dissipation. And then on the layout side, the thermal simulator will read in the power dissipation and write out the temperature, and you have this kind of iteration until your power dissipation and temperatures are all settled, not changing anymore. Okay, so this is how the thermal works. So looks like if we want to do the thermal, we want to have the schematic on ADS side, and we want to have the layout on the ADS side as well. So if you have an interoperable PDK, okay, and here I'm talking about a full interoperable PDK. What does that mean? That means your schematic and the layout are both interoperable. Interoperable means that, well, if I enter my schematic on the cadence side, and I can open exactly the same thing on the ADS side, and vice versa. It's the same database. Whether you can enter it from ADS schematic or you can enter it from cadence side, it doesn't matter. I mean, you can open it in the other environment. And if one is opened, then, and here you try to open the same cell, it will just say it's a read only because you are looking at the same database. And for the layout side, it's a little bit different than the schematic side. So still, if you open the virtuoso layout, you can open the same thing on the ADS side. And for the fully interoperable layout PDK, for the user, it looks like you are dealing with the same database, but actually there's only one thing that's different. That's called the P cells. Okay, so the P cells on the cadence side is written in skill code. But in ADS doesn't take skill code. In order to be able to edit the P cell, you will need to use the AEL code to write the equivalent of the P cells. Okay, so this is the part that you need to do. So like, Global Foundry, SOI, ASW, they have this fully interoperable PDK. So they did this job. So that's why even if you have a P cell, you can either edit here, you can edit here. So for this fully interoperable, right, we just now talk about the PDK, but what about the thermal flow? This kind of thermal flow is very easy, right? If you can manage to tell the foundry, say, hey, could you add a heat layer for me on the cadence side, right? if they do here, then it will go with the P-cell everything, and by the time it goes to ADS, it doesn't matter which shape you have, and then on ADS side, I don't even need to editing anything. I can just run eThermal. So if you have a fully interoperable PDK like 8SW, I would suggest you to go and tell GlobalFoundries, hey, could you add the heat layer for me on the Virtuoso side? Just get the thermal information there, right? And then we can actually work with the foundry to help you to realize this. But all you need to do is just to make the request on both environments. But the other one is called a schematic only interoperable PDK. So this kind of PDK, everything else is the same except on the ADS side, they didn't do this job. Okay, so then you only have this P-cell here. And when you have a P-cell here and you open it on the ADS side, so everything else will come over, including this hierarchy, everything of the layout, right? The only piece that doesn't show up is the P-cell. Okay, so what you do is you can come over here. You can kind of take a picture of it, do a screenshot, right? So that process, we call it express P-cells. So express P-cells will freeze the shape. And then when you go here and it will open, you're going to see a screenshot. And if you want to edit the dimension, you would need to go back to the cadence side and then go through the express P-cell again and then shows up in ADS. For the schematic only interoperable PDK, it would be nice if they can do this as well, okay? Or the CAD team can do this sometimes, right? So then you can do the eThermal. Basically just bring the schematic on the ADS side and then you can do the eThermal simulation. Okay, so now goes to this Virtuoso only PDK. Sometimes you don't have any link with ADS and you just have a pure plain Virtuoso PDK. And with this kind of environment, right, situation, you can use the Dynamic Link eThermal flow. So the way to do this is that let's start with one component, okay? So you have one component on Virtuoso schematic, and then through Dynamic Link, and you open it on ADS side. Okay, so this is the schematic side. And on the cadence side, you go to this Virtuoso component here. Then through the express P-cell, you are having equivalent ADS layout here. And then I want to add the heat layer this point, right? And let's say for this PDK, nobody is going to help me to add any heat layers here. So I will need to do it on ADS side myself. Okay, so in that case, I would need to create an intermediate cell under ADS library, because there I will be able to insert this guy as a subcircuit to here, right? So I have all the content, and also on top of it, I have a different library now, right? Because this is ADS library. So on top of this library, I can add the heat layers, okay? I can't directly add heat layers here because it's a cadence library, right? Probably I don't have the permission to go and change it, okay? So this is my plan. And then after that, you can do the top level eThermal test. And this is a step one, because right now I'm doing it for one component, and you will need to do it for like several different components. Okay, and let's say I just have a small circuit, I have 10 of them, so you will need to do this for 10 of the components. And after that, you're going to put them together on the ADS side, run the entire circuit. The simplified method is that, well, if your CAD team, or I don't know whether Foundry will do this, right? If they can also add the heat layer here, by the time you go here, you do not need to add any heat layers, and then the hierarchy is just a match. So after that, you can put multiple components together.